May the 21st, 2020. Guys, you're looking at Comet Atlas, and this was 5 days ago on May the 12th, and it's from Walter Brocaet from the Netherlands. These are the best I've seen. What's happening, you hadn't seen a lot of the Atlas pictures lately because now it's getting close enough in its dive between Mercury and the Sun that the glare of the Sun is making it difficult to observe. But this one, again, 7 days ago, is amazing to me because it shows in detail how many different objects are traveling with this comet. Again, the close approach is 10 days away on May 31st. And right now, JPL, or the Jet Propulsion Laboratory in Pasadena, is tracking 6 of the objects, including the initial core of this thing. But look at the spread on this. The last video I did on Atlas, they were tracking 5 objects, and the spread of where the objects were going was a little over 250,000 miles. But now they've got 6 objects they're tracking, and that spread is going to increase somewhat. Nothing is predicted to hit the Sun, but again, the smaller fragments would not be that great of an impact. But it's, to me, it's quite a view of this thing because I've watched comets for 10 years, and with the telescopes from space and ground-based telescopes and things like that, we've analyzed them and looked at them. And initially, when we first saw Atlas, I started saying that it had a multiple nuclei because you could see different hot spots on the zooms and as you went through the filters. But this is amazing to me. But some of the other pictures that he took and put into his computer are very fascinating. I've never seen anything quite like it. Now, this is also May 5th. It looks like the same image, just he went through it and filtered it to bring out the hot spots. I've done it many times, but these, I haven't altered these at all. He's done this, but look at that, guys. It's amazing. It's diving down now, and I'm going to show you the JPL. But as it gets closer to the Sun, it's going to become more difficult. But you're going to see a scattering of this because as we have watched comets in the past, as they came across, as they were heading into the Sun, they would come across the orbit of Mars, doing about 1 million miles per day. But as they get closer to the Sun and that gravitational pull is about to slingshot them back out into space, they can approach speeds of 11 million miles per day. And that, imagine the G-force. And so it's going to scatter this thing out further. In the future generations, you'll have a new meteor shower. But look at that, guys. And I'm going to show you a close-up of this. And again, it's amazing just looking at it this close. You can clearly see that inside the core of this fragmentation, this dividing of the multiple nuclei, you can see a couple of other large objects still there, but I've never seen anything quite like this. Again, thanks to Walter Brocaet in the Netherlands, amazing images. Guys, and here's one other image. This is from Michael Jaeger out of Austria on May 12th. And this is what you're seeing is just a further away view, and you can still see that green glow. But it's starting to dive towards the Sun, and I'd like to show you that model. If you look at the JPL database on this, you type in Comet Atlas JPL, you'll see that now you're getting 6 different objects. The initial object, Y4, and then Y4A through E. And we're going to look at the tracking on the main object because you can tell they're still tightly bundled, but they're over 250,000 miles apart on the day of May 31st as they continue to spread out. Now, this is the current model as of today's date. Notice May the 21st. And what you're looking at in this JPL model is the Earth is here, and Comet Atlas is above the inner solar system. Let me kind of pull it straight up and give you an idea, kind of flatten this out. But Atlas is above us, and above the inner solar system. It is between Mercury and the Sun at this point. You have Venus and the Earth here, Mars to your right. Now, I think tonight Venus and Mercury are going to have a pretty good alignment for you guys that have got clear skies. So look into the west, of course, because you're looking towards, as it will be after the sun sets because of the glare. And because of that glare, if you look from the Earth perspective here, you're getting very few images because of that glare of the sun, getting closer there. But as you go further in time, the close approach again will be May 31st. And we've got, again, probably with the new object around 300,000 miles scatter shot on that. But when it reaches that point of perihelion, that turn into that hard curve because of that gravity, you'll see a scattering. And if you look at it, it's not a long-term comet. It makes it out to just past the outer edges of our solar system. And then at that time, the gravity of the sun takes back over and it starts its trip back through. And again, from the ecliptic, we'll pull it back up, of the inner solar system, you can see on this scale, Earth here, Mercury, and it's coming down below us. I'll play this forward. We'll go through the next 10 days as you see it drop. Notice your timestamp. We're at May 29th, 30th, and 31st. That's its closest approach to the sun at that point. And then the gravity will take back over and will again reemerge out the southern side or the bottom side of the inner solar system. And again, guys, if you got a chance, you got good weather, check out the alignment of Venus and Mercury. It should be pretty neat tonight. While we're taking a look at the JPL, let's put in Comet Swan, C2006 M4 Swan, and it's doing just the opposite. Instead of diving down through the solar system, it has been rising from below us and now is about to get into good view in the northern hemisphere. We look at it, we'll realign Earth. You see Venus and Mercury. And if we pull it down, you can see that it rose between, as it came up into the solar system, or to the upper northern solar system, it came between the orbit of Earth and Mars. And when it dives back out, it will be outside the orbit of Mars. So just that long slingshot projection there of the comet as you back it out. It's a little longer period comet. You can see how much greater the distance is way outside the orbit of Neptune. Now, I want to say something. I think something's off on the numbers here on the distance, because it's saying on this date, May 21st, 2020, that the distance from the Earth is 31.9 AU, sun distance 3.136 U. But again, I think the numbers are off. The Earth, from the distance from the Earth to the sun, right there, guys, is 1 AU, about 93 million miles on average, because the orbit is not a perfect circle. And so you can see that it's rising between the orbit of Earth and Mars now. And so something's wrong here. That would be closer, as far as distance from the sun, to 1 AU, because you can see where the Earth is and how close it's rising to the Earth's orbit. At the most, it would be 1.5 AU. So the numbers are not quite right there, but I just wanted to show you this is the other comet that's rising, and it's currently on our Stereo A satellite. I'll show you a couple images of that also. But I'll look deeper into that and get into some of the detail, and we'll look at the AU. But you can tell it's really no threat to the inner solar system. But it's going to be higher in the orbit. It still would be kind of sun-facing. But we're starting to get excellent images of it, and it will continue to do that as it orbits out again back into the solar system. And this is kind of an amazing picture of Comet Swan. This is a few days ago before it rose into the inner solar system. But you can see how long, and it's a spectacular image, and you're seeing different angles on these tails. But notice this part right here, and this is when it comes in contact with either solar flare or an increase in solar wind speed, something like that, and it will disengage that tail and then it will reconnect. But you're seeing the debris trail, which is this long trail that's kind of waving in and out, but there's a very straight tail here called the ion tail, and that ion tail is blowing directly from the sun. Again, it's scattering debris from the comet, it's waving back in this direction, but if you could look at this from a straight down view, you would see that ion tail is pointed straight towards the sun, because that's where the energy is coming from that's causing these comets to react. And guys, it's in a very electric universe. I want to show you a couple things that are currently on stereo A, and some from a couple years back when we were in the peak of solar cycle 24. Guys, what you're looking at is from a few days ago. It's going to go through the 14th through the 18th when I play the video. And it takes a couple of days for the images to get from this satellite back to ground base, get it processed, and up on their website. This is a stereo A satellite. What you've got in the Earth's orbit, on one side of the sun or one corner is a stereo A satellite, and on the opposite side, on another corner of the sun, all in Earth's orbit, is called stereo B. Now, B, we're not getting as much information from there. Both satellites are beyond their expected age, and both have been bombarded by many solar flares. So it really degrades the quality of the imaging, but it's very fortunate that we still have them there. What you're looking at, this object to the right, is one of the wingtips of this satellite, stereo A. And this camera is HI2 or H12. And the Earth is right here. And the reason it's going to stay stationary as everything's orbiting around the sun, 1 AU out, is because we're in the same orbit, and we're focused. The stereo A is focused backward at Earth, and that's why this object will stay stationary. You'll see Mercury and Venus moving more. In this area, you're going to see Comet Atlas rising into the upper solar system. I'll pull a close-up, but I want you to notice a couple things. We're in grand solar minimum, and everything's very calm. There's not a lot of solar activity going on, even with the comets around right now. And what you're looking at here is our Milky Way, guys. You've seen it if you've had very good views of the skies. The best I've seen it ever was on top of Bell Rock at night in Sedona. And but anyway, that's what we're looking at here. Again, the image is somewhat degraded. Let me play it forward. And if you could imagine looking out the window of a spacecraft that was ahead of Earth in orbit, orbiting the sun, looking back, again, center object is Earth, this is what your view would be. Now, in the left, you may not see it that good right there. If you're especially on a cell phone, I'll pull it up a little closer, but that is Comet Atlas. It just rose north of our ecliptic, and it will loop over. The sun is to the left here, and that's what you can see. It loop over the sun and come back out outside, or come back down below us outside the orbit of Mars. Now, maybe on this close-up, you can see the comet right there, guys, right in front of the cursor there, and it's rising right up at that angle. Again, that is, excuse me, I said Atlas, that is Comet Swan. Let me make sure I've got that corrected, guys. But that's Swan, and it is rising. Now, again, look at how calm it is during this solar minimum. Now, same camera, different imaging altogether. You can see flickering in the background, the Milky Way. The Earth is centered, and Mercury and Venus are here. And this shows the comet a little clearer right there. That it looks like smoke coming from the tail. That's the debris trail, but the ion tail is not visible here. But you can tell the sun is to the left, and you can see some solar energy in the solar wind pushing that way. And here's a close-up, guys. Maybe this will make it a little clearer to see, again, the energy of the sun, which is to the left, and Comet Swan rising with Earth, Venus, and Mercury. Now, let's look back a few years ago. Now, I want to look back, guys, to 7 years to 2013, when we were in the peak of solar cycle 24. You'll see a big difference. Now, I want to go back 7 years. Look at your timestamp. This was in November 2013, and you're going to see two comets coming here. In the center is the Earth, stationary because we're in the same orbit from this satellite, and you see Mercury rising. You're going to see Comet Inky coming in there, and then the much larger Comet Ison coming in there. They kind of cross over and under each other as they approach the sun. Look at the reaction during solar maximum. Look at the explosiveness of the sun. And notice that the Earth and Mercury are taking hits also, and we were seeing a lot more quakes during some of the big solar flares. As a matter of fact, a solar flare took out Fukushima. But guys, look at that energy compared to what it is now. And we're starting to go into solar cycle 25. It's not supposed to be as strong. Again, here's inky ISUN. If you could see, there was also comet sighting spring was rising, but it's not visible in this image. But look at the difference that we're seeing. This is an electric universe. Let no one tell you that these are icy snowballs. Think of the friction that occurs if you walk across a carpet and you touch something metallic or electric, that you get shocked with that spark. That same thing happens on a much larger scale as these comets travel for millions of miles collecting a charge. And they're the opposite charge of our sun, and look at the reaction. And the sun's already active during the peak of each solar cycle, 11.8 years. But the comets react. And it was an amazing thing to watch. Even if you look up some of these comets, and I've showed them before on some of the other satellites, tremendous energy being released from our sun. So you're seeing that discharging effect. And the inner solar system definitely is impacted when you see that. But right now we're not. We're starting to see activity on the sun, saying we're going back into solar cycle 25. Now, it's not supposed to peak as high as 24 was. That's because we're going into a solar minimum series of cycles called the grand solar minimum. We're going to be watching and see. Again, you've got 11.8 years between the beginning of a cycle. You go not quite 6 years to the peak, and then it drops. So in 2013, we were very close to the peak of solar cycle 24, and then we started to bottom out. We're going to start seeing more activity as we go forward into the solar cycle. But guys, it's just amazing the difference, and it's amazing to see the energy that can be discharged from our sun during that time, especially in reaction to these comets. We're watching it. You watch it, guys. Subscribe to the channel. It's a heads up. Be safe.